Good morning, everybody, and thank you for having me once again to share some thoughts with you in research methodology. Before I commence, I want to ask if you all can see my slides.
Yes, we can, sir.
Awesome. So I'll be talking about results of quantitative research in the next few minutes, and like Dr. Lawal said, to allow us some time to interact and discuss. So as my normal practice, I always like starting any topic on research methodology with the research process. And like I said the last time, it starts with the question, the research question, after which you go and check the literature, that's literature review, to see what has been done in that area. And after all said and done, if you think you still have a research gap, you can generate your hypothesis. If it's a study that requires hypothesis, or you just continue. And that is by choosing an approach for your study and the particular designs that you will use. Then you calculate your sample size, you will sample the people you need for your study. You have your variables and measurements, what you are going to be collecting, and that will be via a data collection method. And then you analyze your data and you come to report presentation, which is basically the hallmark of this seminar. That's manuscript writing, because you are trying to present your findings for people to see. So it is assumed that we have done the data analysis. What we are trying to do now is to write the result of our study. That is for the quantitative part. If you have done a quantitative study, we are at that level of trying to put out our study for everybody to see. And there's no way I can be talking about the results of a quantitative study. There are some terms that I would like to quickly talk about to more or less brush and refresh our minds, because most of our discussions will center around these terminologies. Number one is variable, and then data, information, and statistics. So what is a variable? A variable is a characteristics that can assume more than one set of values, something that changes. For example, your height. 2-3 years ago, for those of you that are still younger, you might not be as tall as you are. Your weight changes. Your age changes. All these are variable. The color of clothing you put on changes. People's marital status changes. Their income changes, educational level changes. Anything that can change is a variable. It's different from a constant that remains the same. For example, this particular constant pi, since I was small when we were taught pi r squared, till tomorrow, it's still the same value, 3.14. So it's a constant, it doesn't change. And it's going to be the same value tomorrow. If I am here in Jos, the value of pi is 3.14. But if I go to Lagos, it's still 3.14. However, the temperature here differs from the temperature possibly in the north, further north, like Kano or Maiduguri, and it differs from the temperature in somewhere like Lagos. So anything that changes is a variable. We have two types of variable. Number one is the quantitative variable. Number two is the qualitative variable. The quantitative variable is further divided into continuous and discrete. The qualitative into ordinal and nominal. The ordinal is also called rank variable, because you can either rank them in either ascending or descending order. The continuous variables are those ones that can have a decimal point in their measurements. All measurements are continuous. Things like height, pressure, temperature, weight, anything that can have a decimal point. Discrete are whole numbers, like the number of people on this platform, the number of children at home, the number of teachers in the school. All of those ones are whole numbers. So that is said. The data are just the raw facts that you need for making your inferences, that you need for calculations. So data are a set of quantitative or qualitative values. Information is data that has been processed, while statistics is just the science of data collection and analysis. So when you take your data through a mathematical operation or you analyze it, that is statistics. Good. So these are the types of data that we have. They are just a reflection of the type of variables. Since we said data are a collection of quantitative and qualitative variables, it implies that data will just be the same type of variables, but now in data form. So we have quantitative data qualitative data, and from the quantitative, we have the continuous data, we have the discrete data, and then for the qualitative, we have the ordinal, and then we have the nominal data. This is just a picture to depict what I'm talking about. So this is data, just a collection of weights, and these are quantitative variables. Information from this data is like 4 individuals are in the category of 25 to 30 kilogram group, and 2 individuals are in the category of 30 to 35 kilogram group. That's just information derived from this data. When we go to statistics, you can see that we now have some analysis. We have the mean, we have the median, we have the standard deviation. So that's a statistic, and it's still a reflection of the data we are talking about. So we have the mean, the median, and the standard deviation. So that's just how to differentiate data, information, and statistics. So data analysis is just the process of transforming crude data into something that you can make decisions on, like information, like statistics. And there are 2 approaches to data analysis. We have the descriptive, and then we have the inferential. So here, this tool now is analyze data, because from the raw data, we have an information we can get from here, we have an information we can get from here. That's just like data analysis in a nutshell. The descriptive statistics refers to information that summarizes or organizes the basic feature of data. So let's say this is descriptive statistics. It can either organize data or it can summarize data. So when we say organize data, it can either be by tables or by charts. When I mean charts, I include graphs, include figures, include plots. So summarize means we have measures of central statistics in a nutshell. Inferential statistics are the ones that you extract from your sample from your data, and you try to make inferences to similar population, which might not be the one which you used. That's inferential statistics. That's where you have, the many other things that helps you to make inference. Parametric statistics, and we have the non-parametric statistics. The parametric are for quantitative data, that is those that are continuous and discrete. The non-parametric are for qualitative data, those are ordinal and nominal data. So that's your data analysis strategy. You have the univariate, bivalent, and multivariate. The univariate is the descriptive differential statistics. Beautiful. So now going to the core topic of this morning, talking about results for your quantitative research. So the results section of your research, here I mean quantitative. The results section of your result is actually the most important part of your manuscript. That's my own view. The second most important, rather, sorry. The most important part of any manuscript, my view, is your methodology, because the methodology is like the foundation. Once the foundation is sound, you can actually, build on that. So the results section is like the second most important part of your manuscript. And by the time you want to be writing on the result, you should have had your analysis handy. That is if you have done it yourself or you have engaged the services of a statistician. So you will have had your documents, or maybe that is a hard copy or possibly a soft copy in your system, having tables, having graphs, having charts, having plots, having all manners of analysis. The aim of your results section is to summarize the trends in your data. Emphasis is laid on the fact that at this level, you don't comment or interpret whatever you are saying. It's just to tell us the results. The essence of discussing the results is for the discussion section. Here, your data can be summarized in figures, in charts, in graphs, in tables, or text, or even in equations. For example, if you are talking about things like regression, you might end up, trying to put your answer in maybe like a small equation to help people to understand the regression line, And when you are writing your result, please put it in mind to also include negative findings. there's something called result bias, where people just want to write significant findings and they don't want to inform people of non-significant findings. Actually, non-significant findings are as significant as the significant findings, so that people can weigh your findings with other studies. So put that in mind. In your results section, you normally start with a description of the study population, that's a bit of demographics, and then you go to the descriptive statistics, then the bivariate and the multivariate analysis section, and your results section can either be in tables or text, but not the two at the same time. What am I trying to say? If you have a table, that is talking about the age of the people, talking about the gender of the people, and you have given us the values in a table, there is no point repeating everything on the table in text again. That is redundancy. So whatever you have in a table, you shouldn't write it out again verbatim in text. That is redundancy. So sometimes you see things like the demographic characteristics of the participants, it's summarized in table 1. So you don't have to pick all the demographic characteristics and write it out again in words. However, there might be 1 or 2 points that are, cardinal, that you can just pick out, something that stands out, pick out and just make mention of them in your write-up, but not to repeat everything verbatim. And when you have tables, you have figures, you have charts, ensure that you will refer to them, in your write-up. Like the example I just gave, the demographic characteristics of the study participants is summarized in table 1. So I've made reference to that particular table. And like I said in the previous slide, always ensure that in your result section, there is no commentary. Don't interpret your result. Interpretation of results is left for the discussion section. So this is just a chart that we are going to use for our quantitative research, results for our quantitative research. It's like in paragraph. The first paragraph, like we said, is like you describe your participants. Describe your study sample. Who are the people you study? Once you are done with that, the second paragraph for your results section is where you talk about the univariate analysis. How many were male? How many were female? How many were married? How many were unmarried? How many went to school? How many did not go to school? How many used a particular intervention? How many did not? That's where you now start talking about univariate. So univariate here means one variable, univariate, one. So you'll be talking about all those demographic characteristics, your religion, gender, location, position in class, all manners of things that you have collected in your questionnaire. After that paragraph 2, you go to paragraph 3, which can be more than one paragraph anyway, because that's where you now start answering most of your research questions. What is the relationship between A and B? What is the association between A and B? What is the correlation between A and B? What is the impact of A on B? I'm using the word A and B to let you know that I'm talking of just 2 variables. That's why it's bivariate. 2 variables, A and B, A and B. When you have a research question that has more than a variable, more than 2 variables, that's where we go to the multivariate, which is towards the last part of your result section. So if you follow this chart for writing your result section, it makes it very easy. So what we are going to do is just quickly follow this chart, to see what will be in our result section. So we start with paragraph 1, which is saying that you should describe your study sample. And I have 2 examples here written out. It says, this study recruited participants from 2 primary healthcare centers, possibly in Ibadan, Oyo State, or Oyo, Nigeria. We included adult patients aged 18 to 70 years old, diagnosed with hypertension, and prescribed antihypertensive medications. Patients with cognitive impairment or lacking smartphones were excluded. That is a very succinct paragraph 1 that has introduced your subject, the sample that you worked on. This is another example. A total number of maybe 100, you are the one that put the number here, were enrolled with 50 assigned to the intervention group using the new textbook, and another 50 assigned to the control group using the old textbook. Baseline demographic and academic characteristics were collected for both groups. That's an introduction, succinct for paragraph 1 for your results section. So we go to the second paragraph, which talks about the univariate analysis, where you say how many patients had what, or how many patients were in this group or in that group. And for the univariate analysis, that was why I said earlier on, the concept of variable is very important. because the type of analysis you have for quantitative variable differs from the kind of analysis you have for qualitative variable. And like I told us, quantitative can be continuous or discrete. Qualitative can be ordinal or nominal. Okay, so this is just an example of how we are going to find them, presented. So I told us earlier on that the univariate variable analysis is the same thing as the descriptive analysis. And these are the kinds of analysis that you can have. These are for continuous variable, where we have quantitative, and these ones are for categorical variable, where we have qualitative. So you can have measures of central tendency, mean, median, mode, measures of variation, variance, standard deviation, range, percentile, interquartile range. You can have the distribution for when you do a measurement, like age, like distance, like gender, and like weight, like height. You can check the distribution if it follows a normal curve. And then you can have plots, for continuous variable, things like box plot, histogram, stem plot, dot plot, line plot, and time series plot. For categorical variable, basically what you have are tables and plots. So these ones are just purely like tables, and these ones are plots, bar graph, pie chart, and Pareto graph. And we'll look at examples of that. So for the measures of central tendency, this is how you just put it. You don't need to generate a table for that. It can come in a sentence. For example, the mean systolic blood pressure at baseline was 135, and in bracket, standard deviation was 12. That's a mean. You can just express your mean like that. Look at another example. And by the way, this can be expressed as 135 plus or minus 12. Once we see plus or minus, everybody knows that what comes after it is your standard deviation. Another one for like a comparative study, it says the mean of self-reported school attendance was significantly higher in the intervention group. You can see the mean, the standard deviation, compared to the control group, mean, standard deviation. So you have reported that. For the median, if what you are doing will require it to be measured in median, it says the median patient satisfaction score for the new appointment scheduling was 4, interquartile range 3 to 5. When we continue, we'll explain something about that interquartile range. Mode is the most frequent occurrence. So the most frequent response for marital status was single. Possibly it was 80%. So you just put the frequency there, or the percentage there, followed by being married and divorced. That is a mode if you want to express the mode in your results section. Standard deviation normally comes alongside the mean. Most of the time, once you are reporting mean, it comes with the standard deviation. Like in the previous slide, the standard deviation is already reported. The standard deviation is reported alongside with the mean. Range is just the difference between the highest and the lowest value in your measurement. The age of participants ranged from 22 to 67. That's the range. It can be any form of a number or for whatever measurements you have done. So for interquartile range, is a type of measure of dispersion. Look at this example. It says the teenagers reported sleep durations ranging from 5 to 9. The range is already here, 5 to 9 per night. And the interquartile range is 7 to 8 hours. What that means is that the sleep duration was between 5 and 9 hours per night, but the middle 50% of the teenagers reported sleeping between 7 and 8 hours per night. Interquartile range is Q3 minus Q1 when we are talking of quartiles. I am giving this lecture with a kind of assumption that we have some basic understanding of medical statistics, because we can't do everything here. This is just talking about generating and presenting our results. So if opportunities arises, we can be discussing those ones in the future. But that is what interquartile range means. Q3 minus Q1, it gives you the range, something like a median of an occurrence. So for the distribution, like I said, you might have some kind of measurement that you want to check the normality test. So if you want to report that, you mention the particular test you have done to check for normality to assess if your continuous data was normally distributed, something like Shapiro-Wilk test. It helps you to determine the measure of central tendency that you are going to use. You can talk about the skew of your distribution. You can talk about the kurtosis. So we have a normal distribution that's supposed to be bell-shaped. We can have a distribution that is something like that. Another distribution that is something like that. You can see this one has a long left tail. This one has a long right tail. This is negatively skewed, and this one is positively skewed. This one is a normal distribution. So from your appearance of your normality curve, you can talk about the skew. Kurtosis is how close or... So taking this one as our normal, if I have something like this, you can see that it is peaked. You can see it has a peak. Or I have something like this. This one is flat. So this one is what we call leptokurtic. Leptokurtic is just to describe your normal curve, and this one is what we call platykurtic. Platy and then kurtic. That is in case you have any of your result that has to do with a normality distribution. So this is a normal distribution. This is negatively skewed, has a long left tail. This is positively skewed, has a long positive tail. You can see the tail here is longer on this side. And all these variables can actually be summarized in a table, especially if you have a continuous variable. You can see this is age. We have the mean, we have the standard deviation, we have the median, we have the mode, we have the kurtosis, we have the skewness, we have the range, minimum, maximum, everything is there. So you can have something like this generated by either SPSS or whatever statistical software you are using, and put it as maybe table 1. And it doesn't have to be age. It can be a CD4 count. It can be anything you have measured. It can be weight. It can be height. Anything you have measured. It can be blood pressure. You just have it like that, and you can paste it as a table. For plots, this is an example of a plot for a continuous variable histogram. It must be well labeled. So I can say this is figure 1, showing the histogram or the distribution of the weight of children studied. You know, it should have a name. I've just given it a sample name. The axis must be labeled. It should be big enough for clarity. You can see that this one is clear enough. And you should be careful with color combination, not to cause confusion and then to hurt people's eyes. And whenever you are reporting in the text, you make reference to the figure. Figure 1 shows the distribution of the weight of the children studied. And from figure 1, one can see that plausibly this particular group has the highest score. That should be enough. You don't have to explain every particular group. Whenever anybody sees the group, the figure, it should be able to understand what it's saying there. This is an example of another histogram combining both systolic and diastolic blood pressure. This is another example of another plot. We call this one a box plot, and it's also used for continuous variable. This is another example of how a box plot can look. They are beautiful if you know how to use them. They tend to beautify your write-up. Imagine having a presentation or a write-up and you have this kind of charts there. It shows that you are doing something like scientific. There's a way it makes you feel as if you are top-notch. And this is another method of summarizing your data. This one is what we call a stem and leaf plot. You use this one for both discrete and continuous variable. We will not talk deep on how it is generated, but it's for you to know that it can be used. And this is another one for to describe your data, dot plot. As you can see, it's more like you can use it for discrete variables and you can use it for continuous variables where you have decimal points. It's just to also express and maybe describe whatever you have done for people to be able to grasp, easily. This is a line chart, and this you use a line chart for a quantitative variable. This is another line chart. In case you have like 3 or 4 different variables that you are trying to measure at the same time, you can have different colors to depict them. And from this line chart, we can see that this particular variable, by 2010 was the highest, just by looking at the line chart. We don't have to be looking at all the data one by one to conclude on that. This is another time series plot. In case you are doing something over time and then you are taking measurement over a long period of time, we use a time series plot. But that depends on the particular type of study that you are doing. So when we go to categorical variables, which is basically more used for qualitative variables, a table can be used. You can use a table either using an ungrouped number or a grouped number. And like I said for figures, your table also must be well labeled. It should have a name, it should have a title. And Sorry, table does not have y and x-axis. That's a mistake. It should be big enough for clarity also. And like I told us at the beginning, you avoid rehearsing all the information in your table in the text. So like this particular, let's assume this is table 2 now. If at all you want to say anything about table 2, you can just pick out the fact that everybody, 59 out of all the people who are very satisfied concerning the particular question you were asking. You don't have to tell us every other thing again. You know, you have already said according to table 2. So we'll check table 2 to look at the result of the other things. And this is frequency. You can create another column where you can then make it percentage, where you put 59 over the total, and then you can be talking based on percentage. That's for tables. This is an example of a table that has combined more than one variable. So this table has gender, it has educational status, it has occupation, and it can be more like that. I just extracted this from a paper that I have with me. You know, so I have male, that is their frequency, that is their percentage. I have educational qualifications, that's their frequency, that's their percentage, on and on like that. You can even talk about their religion, you can talk about their marital status, and then you can have a very lengthy table where you have combined and summarized a lot of information succinctly in a small table. Okay, so for the plot also, you can have something like a bar chart, you know, for categorical variables, not continuous variables, please. A bar chart has this cardinal feature of having spaces in between the bars, as you can see here and here also. There are spaces in between the bar. You use it for qualitative variable because they stand like categories. They are separate, one from the other. Pie chart is also something similar to a bar chart. They are also used for categorical variables, for qualitative. From here, one can see that Germany, you know, is the one with the largest proportion, while Australia is one with the smallest proportion. This is another design of a pie chart. This is a design of a pie chart that we are trying to discourage. And as you can see, they are trying to put the values inside the pie. And some of the pies are very small and it makes it challenging to see. This is a better way to do it, where the values are put outside using a line just to draw it out for people to be able to see clearly. But what I'm trying to bring out for this one is that it is used for categorical variables, that is qualitative, QL. You can combine a pie chart and a bar graph because they're actually saying the same thing. It makes your appearance, your results to look a bit more appealing, just more beautiful. That was just a combination chart. And then you can have what we call a Pareto diagram, where we have on the lower side here, we have the bar graph. On the upper side here, we have what we call the OGIF curve. That's the cumulative frequency curve. And it just like summarizes two different parameters on one chart. It's a beautiful plot that you can use to represent your results. So let's go to the third paragraph where I spoke about bivariate analysis. And by bivariate, it is talking about, you know, two variables. Look at the sample here. What is the relation between your outcome and explanatory variable? What is the association between A and B? What is the correlation between A and B? What is the effect of A on B? What is the impact of A on B? So if those have been part of your research question, in paragraph 3, that's where you start talking about them. And this is where it comes in the bivariate analysis, where we have two variables. And it has a lot of analysis. You know, if your X, which is your independent variable, is categorical, and your Y, which is your outcome variable, is categorical, you can do a chi-square, you can do a Fisher's exact, you can do a Mann's Magnim's test. And if both of them are continuous, that's where you do something like a scatter plot, a correlation, you know. If one is continuous, one is categorical, that's where you have your t-test, you have your ANOVA. All these things I assume you have idea on, because once the analysis has been done, what we are talking about today is just to report it. So in this particular paragraph, you clearly state the hypothesis that you generated ab initio. You know, you identify the test that you use to evaluate the hypothesis. You provide the result of the statistical test, which most of the time is written in text. And then you state the result of the hypothesis. Either you accept or you reject, or you fail to accept your hypothesis. So if it was a chi-square, this is the sample, or this is the model for reporting a chi-square. You have your chi-square, degrees of freedom, the sample size, the statistics, and then the p-value. So this is an example. The relationship or the relation between these variables was significant. Your chi-square was 1, number of sample was 84, and the chi-square value was 8.9, p-value 0.0029. I want you to notice something about the p-value, the n, that they are in italics. That's how you report those letters, those statistical letters, notations, or shorthands. They are in italics. If it was a correlation, look at this example of correlation. Hours spent studying and GPA were strongly positively correlated. That was the correlation coefficient, R. This is the total number of people that was sampled, 123, and the value of R is 0.61. The P is equal to 0.011. Notice something with the P for the two that I've given example here. I'm not saying less than 0.05. I'm not saying greater than 0.05. I'm giving the actual figure, and it is better you do that if you have it. You give the actual figure, don't just summarize. So hours spent playing video games and GPA were moderately and negatively correlated. The R value is also there, the value of the coefficient is there, and the p-value is also there. That's how you state your correlation. For a t-test, there are three types of t-test. We have the one sample t-test, we have the dependent sample t-test, we have the independent sample t-test, and I have example for each of them. So for the one sample t-test, students taking statistics course in education at the University of Lagos reported studying more hours for test. That is the mean of the hours of test. The mean is 121 hours, standard deviation 14.2. I told us mean and standard deviation are always reported together than students in UI in general. And that's our T value. T also is in italics, and we have our degree of freedom there at 33. What's it called? And the T value is 2.10. Our P is also given there. For the dependent sample, here you are talking of two mean. So we have the mean for the first group, that is M equals to 3.45. The standard deviation goes along with it, and then for the other group, which is the one for egg roll, the mean is 3.00 standard deviation. The T value was given as 4, and the P value 0.001. For the independent sample t-test, UI students taking statistics course in epidemiology had higher IQs. We have the mean, we have the standard deviation than those taking statistics course in global health. We also have the mean and standard deviation, the T value, and then the P value. So this is how you report t-tests. For ANOVA also is another interesting topic. You can have a one-way ANOVA, you can have a factorial ANOVA, you can have all manners of ANOVA, but this is the basic type. So if you have a one-way ANOVA, you can, all these empty spaces are where you will put in your variables, the independent variables and the dependent variables. Anything to do with ANOVA has to do with more than two groups. That's where ANOVA comes in. If it is two groups, it is actually a t-test that will have been ideal. So I have here an example of how to report a one-way ANOVA. An analysis of variance, that is ANOVA, showed that the effect of location was significant. That's the F statistics. The degree of freedom in the first group, degree of freedom in the second group was 5.94. If you look at the letter F, it's in italics, and then our p-value is 0.007. Post hoc analysis using Skefe post hoc criterion for significance indicated that the attendance score was significantly lower in JOS. We have the mean for JOS than in the other two locations, Oyo and Lagos combined. We have the mean for Oyo and Lagos combined, the standard deviation, and the F value. So this particular example, I just have it in mind that I'm trying to show the effect of location possibly on academic performance. So my independent variable here will be my dependent variable will be the location. Let me read it. One way subject ANOVA was to compare the effect of location and educational performance. So this one will be location, this will be educational performance in maybe JOS, Oyo, and Lagos. So if that was what my research question was, it will come out something like this. But like I said earlier on, I can't start explaining in depth what all these figures mean, and even the post hoc analysis, that one we can discuss whenever there's a chance to talk about ANOVA as a lecture. So ANOVA also can be represented in a table. So all those jargons you saw in the previous slide can just be like this, and anybody who is scientifically minded, we understand what you are talking about, seeing this kind of a table that you are actually reporting the finding of your study. So this can be like maybe table 3 or table 4 in your results section. You can have scatter plot. Scatter plot is another way to represent your correlation finding. And then you can have your correlation also in table. Instead of just saying R value, you can put it in a table form. And then you can have equation, like I told us ab initio. This is an example of a linear, simple linear regression equation, where your dependent variable is here. That's the constant and the intercept. And then you have the variable and the coefficient of the variable. So this one is for a simple linear, this one is for a multiple linear, where you have more independent variable. The equation can be longer depending on the number of variables you have. So going to the last paragraph, where it might be multivariate, and multivariate here means greater than 2. Bivariate is 2. Bivariate is 2, but multivariate means greater than 2. It's still the same thing or similar idea with what we have been doing. In the multivariate analysis, there are different types, things like multiple regression, logistic regression, ordinal logistic regression, repeated measures, factor analysis, analysis of covariance. There are many analyses you could have done, but what we are talking about today is how to report them. So normally you start with your hypothesis, and the test that you use for your hypothesis, you provide a result, and you state the result of the test. For example, hypothesis 1 predicted that income, just hypothetical, that income, age, and body size will be significant predictors of hunger. This is hunger I'm supposed to put here. Okay. The overall regression was significant. We have the F value, the degree of freedom 1, degree of freedom 2, and the value of the F value, yielding a small effect. R here and R squared, those are the coefficient of determination. Those are the values. The hypothesis was partially supported. Only age significantly predicts hunger. We have the beta value, the T value, the P value, and the confidence interval. So this is how you will report a multiple linear regression. That's just a good example of a multiple linear regression. And you can also put it in a table form. But if you report it like this, you have done very well. That's an example of a regression table, a multiple regression analysis for student score. That's your beta, that's your T value, that's your P value. Something similar to what we had in the previous slide. And that's another bigger table, for a multiple linear regression, where you have many independent variables, unlike just one in a simple linear regression. There's many independent variables. And for this one also, even instead of putting it like a table, you could have it, as, as an equation, plus b2x plus b3x plus b4x dot nx. So n now means the total number of variables. So it can be long. You can represent all these things you have here on this table in a long equation to depict all the coefficients of what each variable has on the dependent variable. I think I will stop here so that we can have questions and entertain comments. Thank you very much for your time.